Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to talk about solving inequalities with one variable. I want you, first of all, not to stress. A lot of people see this word inequalities and they say, oh my God, what's going on? Don't let it stress you out. I'm going to tell you right now, right off the bat, it's exactly the same as solving equations. There's just one exception, and we're going to get to it, but real quick, whenever you multiply or divide by a negative from one side to the other side, you got to flip the inequality sign. Other than that, it's identical to solving equations. So what I want to do, though, is not just teach you how to solve an inequality, but I want to teach you guys properly, okay, how to work with inequalities and how to write solutions in both what's called Setbuilder and interval notation. Interval notation is where mathematicians, that's how they write their solutions. That's how you're going to, for the most part, see your solution on SATs and ACTs. And for my class, that's what I'm going to want is interval notation. So let's get right to it. If you're talking about an equation, guys, we use equal sign. Hence, equation, equal, no big deal. Inequalities are a little bit different, okay? You have, when you're going to use an inequality sign, you can have less than, you can have greater than, you can have less than or equal to, which has the less than, and it also has a line underneath that. It means less than or equal to. It's either or, okay? You can have a greater than or equal to, or you can have a not equal to. Those are the inequalities. It's going to be one of those five, period. It's just the way it goes, okay? So learn them, love it, and live it. Whenever we're talking about inequalities, I want you to understand, though, that you're always reading from the variable in question. If there are no variables, then you could read left to right or right to left. It doesn't matter. But if I'm talking about variables, I always read from the variable. And I'll explain what that means now in a second. Before we get to actual computation here, another thing I want to talk to you about. When dealing with word problems, remember that is at most. What do you think is at most means? Is at most is going to be less than or equal to. Very well done, son. Very well done. For example, John is at most 40 years old. Well, that means that John is either 40 years old or less. Okay? You guys are at most 17. It means you're 17 or less than that age. All right? So is at most, very important, less than or equal to. Is at least. Is at least. What do you think is at least would be? Yes, sir. That's exactly correct, my brother. It's going to be greater than or equal to. Same example, same dude. John is at least 40 years old. Means that John is 40 years old or more or older. Okay? So with is at most, Johnny would be less than or equal to 40. Is at least, Johnny J would be greater than or equal to 40. Yes, sir. It is not the only way to represent. You could say is less than or equal to or is greater than or equal to. The only problem here is that in word problems, especially at our level, they're going to be saying at most and at least a lot. And I just didn't want that to catch you by surprise. Thank you, sir. May I continue, gentlemen? We're good? Thank you, brothers. Okay. Okay, so now, Setbuilder, guys, okay? There's two ways to write inequality solutions. Setbuilder is what you've done all your life, except they didn't really let you or teach you how to write it correctly. We know what a set is already. We've talked about sets. A set is an accumulation or a collection of things, items, numbers, things, okay? It's a collection of things. When we're talking about set builder notation for inequalities, this is the basic way of writing an inequality. And the way it works is as such. If you see this guy right here, you've got these little braces. These are called braces. I'm not looking for art, but those are braces. Then you have this variable here. That is the variable in question. You're just telling the reader, hey, dude or dudette, listen, this is the variable I'm going to describe right now. Then there is literally a straight line that goes down, because again, that tells the reader, hey, dude or dudette, listen, I'm going to talk to you about X right now. And in this particular case, X is less than A. And then I close with braces. That's a set builder. So let's say that we're solving an equation, and the answer to my equation at the end of the day is X is less than 2. Using set builder, my solution would be braces. I'm talking about the variable X, and the description of X is X is less than 2. That's set builder, y'all. You got to know how to read that. It's not extremely used a lot, but it is used for the most part. Okay? So please pay attention to that. Please make sure you know how to write set builder, okay? And it works for all of them. Less than, greater than or equal to, or less than or equal to. All right? So for example, if you have these solutions, I tell you write in set builder notation, this should be a joke. For X is less than 5, you're going to write your braces. X is the variable we're talking about. This line then tells the reader, hey, this is how we describe this solution, and it's literally X is less than 5. So there's literally nothing that you have to add to your solution for set builder except for the braces and then this part that defines what variable you're solving for. That's all set builder is. Just for giggles, instead of this being an X, make it a Y. Just so I can show you, it's not going to make a big difference. It's going to be your braces, but this time the variable in question is Y. And then the solution for this is Y is greater than or equal to -2. And then we have our braces. X is greater than 3. We have our braces. The variable in question is X. And the description of my solution is that X is greater than 3. And my braces to close it off. So set builder, pretty simple. Again, you have all been doing this your whole life pretty much already, except they may not have actually encapsulated it for you in a proper set builder notation. But that's pretty simple, right? No questions on that. Okay. Now, graphing inequalities. When we're graphing inequalities, my friends, I'm sure you guys remember graphing it with open circles and closed circles. That's a thing of the past. Now we're going to use proper symbols, okay? When graphing inequalities, I want you and I need you to remember that when dealing with less than or greater than, you're going to use from now on parentheses. You're not going to use an open circle anymore. Parentheses states, hey, dude or dudette, the reader of this problem, this number is not included in the solution. Okay? For example, if I have X is greater than 4, you would go to the 4 back in the day, you put an open circle on the 4, right? Well, now you're going to put a parentheses. For less than or equal to or greater than or equal to, my brothers, you're going to use what's called brackets. And this is not just because I say so. This is the common math language across the world. So that's the beauty of math. If you were in China and you wrote these symbols in an inequality, you may not be able to say hello to that person, but they can understand your mathematical solution. And that's pretty cool. All right? If we go to Buenos Aires right now, even if you don't speak Spanish, it's fine. That solution is universal. That's the beauty of math. And now, always, just so you know, a little heads up, whenever you're dealing with infinity, you're always going to use parentheses. Infinity plus or minus always uses parentheses. Yes, sir. Yeah, this guy right here is just plus or minus. Thank you, my man. Now, the reason why infinity is always a parentheses is because you can never equal infinity. You can never find a finality for infinity. Infinity goes on forever and ever. So since you cannot have a finality for infinity, you can never really make it equal anything. Infinity is boundless. It never ends. So that's why you can never say, oh, let's encapsulate it with a bracket. Yes, sir. We're going to give examples now in 2 shakes of a lamb's tail. Thank you, sir. All right. So, for example, let's graph each solution here, okay? So I've got here x is less than 5. All right. So I'm going to go ahead and put a little number line. Here's my 0. I'm not too much of a stickler. As long as you put your 0 as a reference point, put your 5. I'm going to put a parentheses, and x is less than, actually I should have put it the other way. Should have put it this way. X is less than 5. So am I shading to the left or to the right? I'm shading to the left. Okay. Sure, my brother. Okay, we had talked about that. The open circle is no longer valid here. That's a thing of pre-algebra, and that's cool. Just remember, guys, no more open circle. Now it's a parenthesis. Yes, sir, my brother. Well, the solutions here are x is less than 5. So it's going to be anything to the left here, correct? Anything to the left here. Okay? So yeah, there's one finality here. It can be anything less than 5, but is 5 included here in the solution? Whoever said yes, no, it's not. 5 is not less than 5. So no, 5 is not included. Now, is 4.9999999999999, etc., is that included? Oh yeah, you got that. But 5 is not. Does that make sense? Thank you, my brothers. Here, x is greater than or equal to 2. Okay, well, negative 2. Here's my 0. Here's my negative 2. Greater than or equal to this time. So we're talking about a bracket. And then we're going to go and shade to the right. That's simple. X is less than 3. Okay. Here's my 0. Here's my 3. Less than 3. Parentheses. I'm shading to the left because all of those values are less than 3. X is less than negative 4. Here's my 0. Here's my negative 4. Parentheses. And I'm going to the left as well. Now, I'm sure that my boy who asked, could you give me an example of the infinity, is probably asking me right now, Mr. Moore, you said you were going to give me examples, and you have not given me one yet. We're not there yet. I'm almost there. I promise. I have not forgotten about you. Right now, I just want you to understand and see how beautifully simple it is to graph inequalities. And everyone understands and agrees, right? It's pretty simple? Okay, now, yes, sir. X is greater than. Why did you guys let me do that? I was testing you guys and you all failed. No, I'm kidding. Morrow made a mistake. It is greater than. Thank you. Good? Promise? Thank you. Good catch. Okay. Now, interval notation. Okay. This is the reason I went to graphing first and then to interval notation. Hopefully will all make sense to you right now. This is a very fancy way of writing inequality solutions, guys. And here's how it works. Kind of similar to graphing. When you're dealing with less than or greater than, you use parentheses. When you're dealing with less than or equal to or greater than or equal to, brackets. And you're always going to use parentheses for plus or minus infinity. Now, when using interval notation, remember that the format will always be parentheses or bracket, depending on if you have a greater than or equal to, or less than or equal to. But it's always going to be small value to larger value. Always. Small value to larger value. Always. And I know you're still right now going, what is he talking about? I promise I'm going to make it all come together right now. Just remember, infinities always have parentheses. And remember, when you're writing interval notation, you go from the smallest value to the largest value. You with me? Okay. Let me show you how this works now, guys. I want you to write each of these solutions in interval notation. Okay. You ready? First, graph it, guys. Because if you graph it, you have the interval notation answer. I promise. Check out what I'm saying. You're all looking at me like I'm crazy today, but watch. Here's 5. There's a parentheses, and it's less than, correct? Okay. Now, guys, as I'm going further and further into the negative realms of the number system, what's the smallest negative I can ever have? Okay, infinity, negative infinity. So I'm going to go parentheses. My solutions go from negative infinity, smallest value, all the way to 5. Parentheses on both. Why? Infinities never have brackets. And the 5 has a parentheses, not a bracket, because it's less than. And now if you look at the graph and you look at this interval notation, do you see now why I wanted you to graph it first? Do you see how all of the solutions of negative infinity, all of those work all the way to 5, and then at 5 it stops? Do you see that, my brothers? You promise this is huge. Okay? X is greater than or equal to negative 2. You got a question, my brother? X is greater than or equal to negative 2. Graph it out, boys. Graph it out. Here's negative 2. There's going to be a bracket. It's greater. So I'm going to the right. So this time, what's my smallest value? Negative 2, you darn right. And now I'm keeping on going forever to the positive. So what's my largest value here? Positive infinity. That's it. Parentheses. Why, Moro? Because parentheses are always used for infinities. Ah, I heard the magical, oh, that means someone's learning. Excellent. Thank you, boys. Now, x is greater than 3. Graph it out, y'all. Here's 0, here's 3, greater than, parentheses, to the right. Who's my smallest value here, gentlemen? 3, which is in parentheses, comma, positive infinity, because it keeps going to positive infinity forever. No, not even a chuckle? Come on, come on. Forget it. That's why I'm not a comedian. All right. Does that make sense, gentlemen? Not as bad as you had anticipated, was it? All right, now, the easy part, guys. Now's the easy part. In order to solve inequalities, simply use the same procedures for solving equations, except for the following. Whenever you multiply or divide by a negative, you must flip the inequality sign. But remember, it's multiplying by a negative, not to a negative. Big difference. Real quick, because I know you got to go. I got 2x is greater than negative 10. I divide it by a 2. I don't change anything there. I divide it by a 2. Now, had this been a negative, then I divide by a negative. Now that had to flip because I divided by a negative. You feel me here, guys? Big difference is dividing to a negative and by a negative. Thank you. Okay, so now I got a few examples here of inequalities. I'm going to go fast, but you have a video, so watch it, okay? Try to keep up with me, boys. Let's do this. Number one, I'm going to divide by a -2. I'm dividing by a negative. So x is, good job, greater than 5 because I got to flip the inequality. I divide by a negative. Let's go ahead and graph it. Here's my 0. Here's my 5. Greater than, parentheses to the right. Interval notation, parentheses 5 to positive infinity. Done. I don't want to work with any fractions here. Heck no. I'm going to multiply this by 15. So that's going to be 20x minus 10 is less than or equal to 12x plus 9. So I'm going to subtract 12x to both sides. And I get 8x minus 10 less than or equal to 9. Add the 10 to both sides. And I've got 8x is less than or equal to 19. So I've got 8x is less than or equal to 19 divided by 8 divided by 8. X is less than or equal to 2 3/8. 2 3/8. Boom. How would I graph that? Well, let's graph that right here. I've got my 0 over here. Here's 1. Here's 2. Here's 3. 2 3/8 is going to be somewhere here. 2 3/8. I've got less than or equal to, so bracket to the left. My smallest value here is negative infinity. And I go all the way to positive 2 3/8, including the 2 3/8. So I got my bracket. Here I'm going to get all variables together on one side. So I'm going to go ahead and subtract by 5x to both sides. That gives me -3 is greater than -x. I'm going to divide by a -1. When I divide by a -1, I flip the inequality. Good job. Heard some of you say that. So x is greater than 3. Please read from the variable. This is not 3 is less than x. No. This is x is greater than 3. So here's my 0. Here's my 3. Open parentheses because it's greater than to the right. And my solution would be parentheses 3 to comma positive infinity. Is everyone seeing this so far? Is everyone with me? Promise? Okay. When the bell rings, you are dismissed. I will finish the rest of these. But please, not too much noise. So first I'm going to distribute. So I've got 12x minus 24 plus 12 is greater than 11x minus 13. Okay, so this is 12x minus 12 is greater than 11x minus 13. I'm going to subtract the 11x to both sides. I got x minus 12 is greater than -13. Add 12 to both sides. So x is greater than -1. My graph, -1, parentheses, greater than. Have a great day, guys. I'll finish these up now. And interval notation, smallest value is -1 to largest value is positive infinity. And we keep going. Number 5, pretty simple. We're just going to go ahead and divide by 6. Now be careful. Even though there's a -42, you're dividing by a positive 6. I'm sorry, yeah, by a positive 6, not a -6. So you do not flip that sign. So y is literally greater than -7. 0, here's my -7. It's greater than, parentheses. I'm going to the right because it's greater than. So my interval notation will be -7, comma, positive infinity, small value to large value. Last but not least here, I'm going to multiply everything here by 15. So that's going to give me -20x is less than or equal to negative 12. You're going to go ahead and divide by a negative 20. When I go ahead and divide by that negative 20, I'm going to flip that inequality sign because I divided by a negative. And here, this is, I can take away a 4. So it's going to be positive 3/5. My graph, here's 0, here's 1. 3/5 is about here. Bracket, because it's greater than or equal to, shaded to the right. Smallest value is bracket 3/5, comma, positive infinity. And there you have it. Hope that made sense. Hope you learned a lot. Thank you so much for a great class, and I'll talk to you later. Bye-bye now.